Hello, this is Dr. Wilkinson. I've helped Mr. Nachman with the Robotics Club for the last several years, and we're going to try to show you a subsystem for the robot you need to build. We want to think about, whenever you've got this robot with lots of parts to it, is you want to think about how you can break it up into subsystems. And one of the ways to do that is to kind of look at where the motors are, and wherever there's a motor, there's likely a subsystem that you can separate out from that. The example I've got right here is drive system for one side of your robot. Here's your motor, your two wheels, and there's a chain to connect the two wheels, so you need only one motor to drive that one side of the robot. And realize when you're doing skid steer that basically each side of the vehicle is controlled separately, and you vary the speed or the direction in order to get it to turn in some direction or some rate of rotation. So let's start with this picture here, or this system first. These are the wheels. They're kind of a funny wheel for what you're used to, but they're great for skid steering because these little rollers allow it to roll to the side easily, but give good traction when you're going forward and backwards. So let's now take a look at this subsystem here, and I guess the whole idea is that with this angle iron or piece of angle metal, you can attach this to the deck of your robot. And your deck can be any number of configurations to attach it to. But let's try to take a look at this more carefully. If we look here, what we'll see is here's the angle. It makes it nice and rigid. It gives it two faces to attach to. One face to attach your wheel and axles and stuff, and then the other face to attach to your deck. And notice this thing has 25 holes along the length of it, and in VEX they make their holes on half-inch centers, so 25 holes makes this a 12.5-inch long piece of angle iron. This is a standard length for VEX and great for the thought that your robot can only be 18 inches long, so your drive system being 12 inches long allows a certain amount of overhang out front and out back before you violate the 18-inch limits. So just going back to the parts, here again is the angle piece, and then here's on this end there's a little channel piece. Again, gives it rigidity, but the whole purpose is that it provides a way to support the axle at 2 points, because the wheel puts a force or a bending moment or a torque on the shaft. You've got to have something else to counter that torque, and that's in this structure here. So this is like the fulcrum of your lever, and this is like one of the loads on the lever, and your wheel is the other load on the other side. So on this end, it's a little different because you have the motor out here, and the shaft is going to go into the motor. That provides the equivalent of this stationary point. Then you have the same pivot point or fulcrum here, and then you have your wheel load out there. So let's take a look at some of the parts. We already mentioned the wheels, and on here there is a little, there's the axle that you can see in the center, and a collar. It's a clamping collar to clamp onto the shaft and retain a wheel or something else in place. There's one on each end. Here's the chain, which is a universal thing. Here's your motor, stands out big. The drive shaft of the motor comes out here. These are, let me do that better. This is the drive shaft. These two are mounting supports for the motor. Again, notice there's two mounts there, again to take care of torques that come off the shaft, and also to give it good rigid, really nice rigid support. Okay, so let's now come to some other parts. In fact, let me take this part right here. This is an example of one of those clamping collars for the shaft or the axle. This is a piece of shaft. They can come in various lengths. You can cut them to lengths as needed. It's a square 1/8 inch on a side shaft. It's quite stiff, strong enough for all of the different uses that we put it to in our Vex competitions. Here's a sprocket. Let me take this collar back off. Here's a sprocket. This is the green thing that you see in here. You have the same size sprocket on each end so that both wheels will turn at the same speed when you're operating. And notice in this, it's got a little small square hole that slips onto the shaft, and that gives the ability to provide the twisting torque to the sprocket. And I'm going to show you, well, another general thing that worth showing you is here's a typical screw that holds things together. Find some of these screws right there and there and there and there, some more down here. But you know, it's an 832. In this case, it's a socket button head screw. Some of what you got have star wrenches in here instead of the hex wrench. This is a typical self-locking nut. These are really good because a lot of times robots come apart during competition, a little bit of vibration and shucking, and the nuts start loosening up and backing off. Well, these won't do that because they're self-locking. They're not permanent, they can be removed, but they go on, and there's a little piece of nylon in here that provides lots of friction on the threads to keep it in place. Show you here just more. Here's this channel that I mentioned earlier to support that axle. This is just a longer piece of it that is used. You know, it can be cut at these special spots to get lengths if you need custom lengths, but there's quite a good selection in their supply kits. I'm going to bring out a couple more useful things here. This is called a spacer bushing. You find one right there, and you'll find some in other places too, and their purpose is to make sure that the sprocket is far enough away from the sheet metal that the chain or any part of the sprocket can't rub on the metal frame. So it's just a way to provide a spacer in there. And here you got a similar thing. You want to put some space between the wheel and the chain so that it doesn't rub. You want some clearance in there. Am I blocking your view? So let's go look more carefully at this assembly right here. I mentioned earlier there's a clamp. Does that show up? A collar, a shaft collar. And another item that's often overlooked but really valuable is called a bearing. It lives, here's a close-up view of it. This face goes against your metal structure, and then some kind of a screw, your choice of screw, goes through here. There's an example of one of those bearings right there. And the benefit of the bearing, okay, here's another bearing too, just keep in mind. The benefit of the bearing is that it keeps the shafts, they're square shafts, and these are square holes in here, and they can get to really clanking and grinding on each other if you don't use the bearings. The bearings keep them centered and keeps the friction low for the shaft. So the next kind of unique thing is the motor. I mentioned that. Here's the control into the motor. It's where the control cable goes in. And again, you've got some collars, locking collars on the shaft to force the position where you want it to be, or to guarantee the position stays where you want it to be. Here's another bearing down here so that this shaft goes cleanly through that hole in the frame angle. Another spacer down in there. I don't know if you can see it from where you're at. And I mentioned earlier the locking collar on the end out here. One of the advantages of these locking collars like this on the wheels is it's pretty quick and easy to pop that off, pop the wheel off, and then you can get to the sprocket and other screws that are in this assembly here. Because once you pull that thing off, then pull the wheels off, the sprockets come off, and you're now into the rest of the structure to take them apart if need be. And being able to do maintenance or part replacements during competitions quickly is quite valuable. So I guess beyond that, I'm not sure what to offer. Another little bit of a tour around on the part. Remind you of this structure here with the channel and the angle together to make this structure here for the wheel that doesn't have the motor attached. At this point, I guess I'd leave it with you and Mr. Nachman to ask questions for clarification. One of the things about any technical work, and it's certainly been true in my lifetime as a scientist, is if you're not full of questions, you're likely not getting your job done, because there's always stuff that you don't know, and you have to figure out what it is you don't know and ask a question to get it clear, and then move on and get your job done. So I don't know what else I can add to this. Enjoy, guys. Build one yourself if you can.